I'm going to take you through the first half of section 1.5. So this is 1.5 part A. And 1.5 goes from talking about equations, which had equal signs, to talking about inequalities. So when you see the term inequalities, the first thing you should start to think of is less than signs and greater than signs and less than or equal to signs and greater than or equal to signs. And we're going to talk about how those relate, and when it comes to solving inequalities, we're going to talk about how we use them in real life applications. And we're also going to talk about how do we write our answers? What are the different notations? And how do I draw it with a picture? So first I want to talk just a real quick about the number line and just some basic explanation with this. So when we think about our number line that extends in both directions, left and right, and we'll just kind of put 0 in the middle here. When we talk about numbers that get bigger or get smaller, you want to think of your number line as starting at negative infinity, which means the smallest it could possibly go, to finishing at positive infinity. And when we come up with inequalities, we're going to look at part of the number line as being my answers. So we could have a situation where my answers are all the numbers bigger than 3. And so we have to figure out how we draw that. How do we write it? How do we put it on a number line? And how do we illustrate that with different notation? So this is going to kind of summarize the different notation that we're going to talk about. So when you hear me say this notation, it sounds familiar. So in the left column, when you see set notation, so set notation is actually with the inequality symbols. There are 4 inequality symbols that we'll work with. Greater than, this is the first one, your greater than sign. Use my little highlighter here. So your greater than sign is the one that looks like this. So this is saying x is greater than 4, or what are the numbers greater than 4. As soon as you put a line underneath it, that's your greater than or equal to. So saying your numbers can include that number and then everything bigger than that. And then when your arrow goes in the opposite direction, that's your less than sign. And then again, when we put that little line underneath it, that is your less than or equal to sign. So those are the inequalities or the set notation, probably what you're most familiar with. The words that go with it are in the second column. So x greater than, we use the greater than symbol, greater than or equal to, that type of thing. So I want to talk a little bit about the graph. When we graph things, when I graph something where x is greater than 4, that means that at 4, I need to put an open circle. And what that open circle was saying is that number is not included as one of my answers. 4 is not bigger than itself, but it's everything right after 4. So 4.1 or 4.2 or even 6 or 7. And then my arrow heads to the right because those are all the numbers that are bigger than 4. And I'm going to go through all the graphs first, and then I'll do the last column. If I want to include 4, if 4 is one of my solutions, then you'll notice that I fill in that circle, that I have a closed circle. So now that I always like to think of it as like I'm filling in because I'm counting it. That number counts. If it's a less than sign, the only thing that changes with the less than from the greater than is the direction of the arrow. Now we're heading in this direction because we're talking about all the numbers that are smaller than 4. If it's less than or equal to, I need to fill in the circle at 4. I call it a closed circle, and then I need to head to the left. So the last column I want to look at is something called interval notation, and this might be newer to you. The rest that what I said hopefully was a review. Interval notation is another way to write your answers instead of using less than signs or greater than signs. Interval notation is giving just what it sounds, an interval of your answers. So if I'm talking about all the numbers that are bigger than 4, 4 is the first number I'm talking about. Notice I put a parentheses around it. That parentheses is going to coordinate with an open circle. So if I have an open circle, if I'm not including that number, I'm going to use a parentheses. And then those numbers are anything that just gets bigger and bigger and bigger going to infinity. If I want to include a number, if it is a closed circle and I want to include the 4 or any number here, I'm going to use a bracket, and that's illustrating that that number is included or a closed circle. Less than is very similar, but less than, you want to think of it as all the numbers that are down here. So if I'm doing my less than, it's all the numbers that start at negative infinity, which is the idea of the smallest you can go, and then stop once I get to 4. The reason we put it in that order, a lot of times students will say, does it matter where I put the infinity? Your negative infinity is as small as you can go. So you always want to put your smallest number first when you're writing it in order. And then 4 is the highest it goes. Notice it is an open circle. It's not included, so it's a parentheses. And then finally, the bottom one, now we're including 4, but all the numbers up until 4 including it, so we have a bracket around it. Great rule of thumb, something to maybe jot down in your notebook. The only time that you will ever use a bracket is if you have a closed circle. Kind of draw it a little bit better like that. That is the only time that you'll use a bracket. All right, so let's get to it. So the first thing you might be asked to do is just write basic inequalities. So 5 fewer than a number is at least 12. Fewer than means to subtract. So 5 fewer than a number means I'm subtracting 5 off of that number. At least. So the wording at least. If I told you that you want to get a summer job and you want to make at least $10 an hour, then that means you would want your pay to be $10 or more or greater than 10. So if I want something to be at least 12, that's going to be greater than or equal to 12. If you're ever stuck, think of things in terms of money and food. Those are the things that people relate to the most. So if I want at least 12, that means I need to be greater than or equal to 12. The next one, when you see the word quotient, quotient should make you think division the moment you see quotient. So it's the quotient of a number and 3. We usually write it with a division bar instead of writing the symbol that you learned maybe in earlier years. No more than means it can go up to that amount. It can equal that amount, but it's not allowed to go over. So the way that we write no more than, that is going to be less than or equal to 15. No more than has to be less than or equal to 15. Again, some of these things, as you're taking notes, I mentioned you can use your notes when you work on assessments for me. Jot those things down so you know what those key words mean in relation to the math that you'll be writing. Here are some properties. I'm not going to do a lot with these properties except for the ones on the very bottom. So here are the properties that I'm going to spend time with: multiplication and division. All of the other properties are exactly the same as when we did equations. You can still add a number to both sides of an inequality. You can still subtract both numbers from the same different sides of the inequality. When it comes to multiplication and division, there is an exception, and this is where you want to jot this down in your notes. If you are, let's say you have something like this: negative 1/2 x is less than 5. And you want to get x by itself. So what you do is you multiply by the reciprocal of what's in front of x. So you're going to multiply both sides by negative 2 over 1, or just negative 2. Here's the exception, and here's what you're going to notice here. If I divide by something that is, it's right here. If I multiply or divide by something that is smaller than 0, then it is negative, it's going to flip my sign. So instead of having a less than sign, it's going to be a greater than sign. It only happens when what I multiply both sides or divide both sides is negative. So because I had to multiply both sides by a negative 2, I have to flip my inequality to a greater than. 5 times negative 2 is negative 10. So that would be the new solution to my inequality. Same thing with division. So let's say it was something like negative 2x is greater than or equal to 8. And I asked you to solve that inequality. You would divide both sides by negative 2. And as soon as you divide by a negative 2, there should be bells going off saying, I got to change it. That means that's going to actually switch to a less than or equal to negative 4. Probably the easiest thing to forget because it only happens in this circumstance. So let's practice. And again, if you want to pause this video and try them on your own and then see how I do them, or if you want to go through one with me and then one that you try on your own, whatever works for you. So first thing I want to do, just like with equations, is I want to start cleaning this up a little bit. I'm going to distribute. So I have a negative 6x plus 15 plus 1. I'm going to add like terms that are on the same side of the inequality. So I have negative 6x plus 16 is greater than or equal to 4. I need to get the x by itself, so I'm going to subtract 16 on both sides. So I get negative 6x is greater than or equal to negative 12. I'm going to divide both sides by negative 6, and immediately you should be thinking I divided by a negative, so I need to switch that inequality. It's going to be less than or equal to 2. That is the set notation answer. Once you get x by itself with an inequality, you have completed the set notation part. As far as the interval notation, so these are all the numbers that are less than or equal to 2, which means it's all the numbers as small as you can go up until we get to 2 with a bracket around it. Those are all of the numbers that go up to 2 and stop and include 2. The graph, I'm going to draw it up high here. I don't need your graph to be fancy. On Delta Math, it often allows you to adjust your own graph. So it will allow you to change it from an open circle to a closed circle, and it'll allow you to change the direction of your arrow. So this is a closed circle. So I'm going to draw it real obvious. I'm going to kind of shade it in like that. And it's everything that is smaller than 2. So my arrow is going to go to the left. Next one, I'm going to distribute. So I get negative 2x minus 18 plus 5, that's a horribly messy 18, is less than or equal to 3. I'm going to add my negative 18 and my positive 5. So I get negative 2x minus 13 is less than or equal to 3. I'm going to add 13 to both sides. So I get negative 2x is less than or equal to 16. Divide by a negative. Again, I'm doing this purposely a lot because it's so easy to forget. I have to flip my inequality. That is the set notation of my answer. My answer are all x values that are negative 8 or bigger, greater than or equal to negative 8. My interval notation would be negative 8 and bigger. So the way I write n bigger than negative 8 is I'm going to put an infinity, positive infinity, because it's getting bigger. And my number line, when I put negative 8 on there, it's going to be, again, a closed circle. So I'm going to kind of fill it in. And it's all of the numbers that are going bigger than negative 8. So those are the three types of answers. You're going to have your set notation, which has the less thans and the greater thans, your interval notations, which is going to use parentheses and brackets, and your graphing notation, which is going to be a picture. Here's a couple more. And again, if you want to try them on your own and then play and watch me here. So negative 2w plus 14 plus 3 is greater than w minus 1. I'm going to combine my like terms here. Negative 2w plus 17 is greater than w minus 1. I'm going to actually do this one the other way. I'm going to add 2w here and here because I want to show you something at the end. So 17 is greater than 3w minus 1. Add 1. And then finally divide by 3. So here's what I want to show you. A lot of times when you get an answer like this, students don't like that the variable isn't first. You want to see, instead of saying 6 is greater than w, you want the w to come first. You can kind of flip this around. 6 is greater than w is the same as saying that w is less than 6. So these two things mean the same thing. They're just two set notation for the exact same answer. 6 greater than w or w less than 6. My set notation would be negative infinity to 6 with all parentheses, because 6 is not included. It's all the numbers that are smaller than 6. And my number line is going to be an open circle heading to the left, because it's all the numbers that are less than 6. A lot of times people like the variable to come first because it helps them draw your arrow. With this one, you can either distribute the 1/3 through, or if you want to get rid of that 1/3, you can actually multiply by the reciprocal right away. That is perfectly legal to do. What that does is it gets rid of parentheses over here, and now 15 times 3 is 45. That's not the only way to do this one. You could have distributed right from the beginning. Subtract 9 on both sides, so you get x is less than 36. My interval notation is from negative infinity to 36 with parentheses, because 36 is not included. And my number line has an open circle at 36, and it's everything smaller than that. Some different word problems that you could see. Word problems for this one, we're trying to figure out our movie rental subscription. So you can either pay $36 a month and rent as much as you want, or you can pay $15 a month and then $1.50 every time you rent a movie. And we're trying to figure out what would make it better to rent. Let's see, how much must you rent in the first month for the first plan to cost less than the second plan? So my first plan is just a plain $36. Doesn't matter if I rent 100 movies, 2 movies, 5 movies, doesn't matter. I want that to be less than if I was going to pay $15, but then $1.50 for every movie I'm going to rent. So you just let X be the number of movies I want to rent. I want to solve this to figure out basically what's my break-even point. When does it make more sense to go with the one subscription? So if I subtract 15, I get 21 is less than 1.5x. I'm going to divide both sides by 1.5. Don't need any fancy calculator for this. Your phone will do, and anything that you want to use, your regular calculator. I end up getting 14 is less than x. What that means is if my number of movies is over 14, it makes more sense to go with the first plan. So I want to do over 14 movies, which means it needs to be 15 or more. 14 would be the total break even. Wouldn't matter which plan. But once I go to 15 movies, if I know I'm going to do 15 in a month, it actually makes more sense to pay the 36 up front. Here's one that's similar with a musical download service. The first one, you pay $9, but then $1 every download. The second one, you pay $25 and then 50 cents every download. And the idea is, how many songs am I going to have to download for the second plan to cost less? So my second plan, the second plan is the one that costs $25, but 50 cents for every download. So 0.5 for every download. I want to know what I have to do to make that plan less than the $9 plus $1 for every download. So I'm going to get my x's on one side. So I'm going to subtract both 0.5x on both sides. So I get 25 is less than 9 plus 0.5x. I'm going to subtract 9. So I get 16 is less than 0.5x. Divide by 0.5. This is not 8. 16 divided by a half is actually 32. So I get 32 is less than x. So that means 32 again is my break-even point. If I do 13 downloads, it's going to be the same no matter what. If I want the second plan to be less, then I need that x value to be bigger than 32. So once I hit 33 downloads, it makes more sense to go to the second plan. The last thing we want to look at are our special cases. We had special cases with equations. We also have special cases with inequalities, and it often comes from the x's and if they cancel, if they have the same amount. So just so you can see some here. So I'm going to distribute. I get negative 6x minus 2, negative 6x plus 7. If you end up with the exact same x's on both sides, they will cancel if I add 6x to both sides. And what you'll be left with is something that's either always going to make sense or never make sense. So I'm left with negative 2 is bigger than 7. That makes no sense. Negative 2 is not bigger than 7. So that means this is never true, meaning there are no x's that would ever make it true. You can also use that symbol I've talked about with that circle with a line through it. If, let's go through this one, we distribute, we get 10x minus 15 minus 7x is less than or equal to 3x plus 8. So I combine my like terms. So I get 3x minus 15 is less than or equal to 3x minus plus 8, excuse me. Again, my x's cancel because I have the exact same on both sides. But now look at what's left. I have negative 15 is less than or equal to 8. That's always true. There's no x's, so there's nothing that's going to make that sometimes true. So we're going to write always true. We could also put like an infinity symbol, say that one's always true. If your x's are different, so if you have 5x on one side and 3x on the other after you simplified, it's going to be sometimes true because you're going to get an answer like the previous ones we did and say, well, it's going to be true when x is bigger than 5 or when x is less than 2. Last one, 8x minus 12 is less than, distribute, you get 8x plus 8. Again, your x's cancel. Take a look at the constants that are left and see if it makes sense. Negative 12 is less than 8. That is always true. Or again, you can write that infinity symbol, or I mentioned this symbol before. This is called the all real numbers sign, meaning it's always true. So those are your special cases. Really, the key is the x's. If you have the exact same x's on both sides, it's either always going to be true or never be true. If you have a different amount of x's, then it will be sometimes because you'll have to solve it and figure out what that range is. So that is the beginning of 1.5. Those are all what we call single inequalities. We'll get to the compounded ones tomorrow.